Because we understand the underlying concepts of how interfaces and abstract classes work, the coding part will now be pretty simple. At first, we will create a Fly interface. So we go to the package, select new, and select the Java class. Here, you'll see that we have an interface option, and that is what we will create. We name it Fly and press enter, and you'll see that the interface is signified with an eye icon. So this is our Fly interface, and here we will have our Fly method declaration. This method is by default public and abstract. Of course, an interface can have attributes as well, but we're trying to keep things simple by only having the abstract Fly method here. So now if we go to the bird class, we do not need to have the abstract Fly method here. And because bird now does not have any abstract methods, it does not need to be an abstract class, so we'll delete this as well. The two birds that we have now are penguin and sparrow. So penguin does not need to override the Fly method anymore because penguins don't fly and we do not need the Fly method for penguins. Now that that's cleaned up, we can go to the sparrow class. Here, the sparrow class extended bird, that can still remain, but it does not need to override the Fly method because bird does not have an abstract Fly method anymore. What we will do instead is that we will make the sparrow class implement the Fly interface. And because it implements the Fly interface, it has to provide the implementation code for the abstract method Fly from the Fly interface. And that is what Sparrow overrides here. So now if we go to the main method and create a Sparrow object, we'll have to give it a name, a wingspan, and a string for size, because that is what we had in the Sparrow constructor, a name, a wingspan, and a size. And the size was a string. So that's what we do. That's how we create a Sparrow object. Remember that Kowalski was a penguin as we had created this object here. But since penguins do not have the Fly method anymore, this is giving us an error. So we will delete this. Coming back to our Sparrow object, we can actually use the Fly method on our object now. And this will work. We just want to see the output of this statement right now. So we will delete these statements for now. And let's run the program. So you can see that we have the output of the Fly method of a sparrow, just like we programmed it here. Right now, if we create another class for bats, and we will have, let's say, this bat class inherit from the mammal class, and let's create a simple implementation of the bat class. So we'll have a Boolean attribute. And again, this is just for example purposes. We then create the constructor, and then we will have a unique method for bat, just for example purposes. And now we start to think about bats having the ability to fly. All mammals cannot fly, so we are not creating an abstract method named fly here. What we can do is very easy. We'll go to the bat class and we will implement the Fly interface. Once we say that we are going to implement the Fly interface, this will prompt us to implement the abstract method Fly. If we do not implement the abstract method Fly, if we do not write the implementation code of the Fly method, then we have to declare this as abstract, and our error would go away. But that means that we cannot create objects from this bat class anymore because this is an abstract class and this is incomplete, right? Because it is implementing an interface but not completing the implementation code for the abstract method in that interface. So what we want to do is not have this as abstract and actually provide the implementation code for the Fly method. And now the bat class also has the implementation code of the Fly method. It has its own version of Fly. This concludes the discussion on interfaces. This was a very simple example, and I hope that the intuition and the usage mechanisms behind abstract classes and interfaces are now clear to you.